Hello, everybody. Welcome to Houdini Hangout. My name is Peter. Thanks for joining us this evening. So tonight we're going to be getting into some clouds and lightning effects. We're going to see kind of what we can get up to here. What we can make out of some cloud noise and things like that. There were some cool new features that were added in Houdini 20 for dealing with clouds and things like that. So that is what we will kind of use as the base for this effect. And then from there, we can kind of make some lightning that goes inside of it. We'll sort of be doing it at least the way... Hello. Welcome, Sprawa. Glad to have you. So we'll mostly be doing this in a pretty procedural manner. I mean, obviously Houdini is procedural from, as much as is possible. But, I think what you might be able to do with this is have, we'll make kind of a setup that should work in a lot of different instances. And in fact, I think it's a kind of cool technique to use for finding paths within a volume anyways. So I think kind of no matter what it is that you're trying to do here, having some of these ideas should be helpful to kind of make something that works for you. I've done some of the stuff that I'm going to show you, I've done in different ways over time. And there's certainly, I'm sure, pros and cons, just like there is to everything. But I think this is a pretty straightforward process to make this stuff. So obviously we'll be getting into that and kind of, navigating through all of the stuff. But that's kind of just the idea of what we're going to be working on tonight. Obviously we'll get into some more details in a second here. So thank you so much to, whoever, I don't even remember who it was a long time ago. So my apologies for not getting to this sooner. It's probably one of the older ones that were in this list here. Let's see, where was it? Topic suggestions. It was a long time ago. Some user Faunalia, something like that, was the one that suggested this. So I think hopefully if you're still, doing the Houdini thing here, hopefully this will be of some interest to you and to everybody. So, anyways, I'm just marking that as streamed because we're streaming it here. So that is the idea for what we're going to be working on tonight. Thank you for everybody that always puts in topic suggestions and things like that. I do really look through those when I'm trying to think of what I'm going to do for each stream. Sometimes I do that way too close to the start of the stream. I think as was the case this week, but sometimes, I've got other things going on. So, so thank you for always putting those in. If you aren't on the Discord server, feel free to go to HoudiniHangout.com for a server invite on there. There are a lot of people that are on there, having conversations and things like that, and like asking about different topics and things for help and ideas and different stuff like that. I try to be in there as often as I can be. Oftentimes I'm more active during the week than I am on the weekends. I just have a lot of personal stuff going on weekends usually. It's weird to have a life, right? I mean, that's a little strange for a Houdini artist, so that's the idea. We're going to, if you want to get involved in those things, you can join the Discord server. And that's free. There's no strings attached to anything. You can also get the files from each stream on there. So if you want to take a look at what I might have done during a certain week, if it was good, then you can do that and take a look as well. So that's the general spiel for this week. If you guys have any questions, comments, any thoughts like that at all, while we're going about and making things, please feel free to put those in the chat. There are no dumb questions about Houdini. Sometimes I say that really, like my mouth has a hard time saying Houdini. Very strange. Anyways, if you have any questions at all about Houdini, happy to answer those. Happy to take a break and get us all up to speed. I always say that if you're have the question, someone else probably does. So don't be afraid to ask. I'm not going to ridicule you. Nobody will. So this is a safe space for any and all questions. So happy to try to answer those if I can. I might not go down every path that people suggest and things like that. But yeah. So question here from Sprawa again. Have you done some streams about HDAs for Unreal? Man, I don't really remember. I feel like I may have at one point. So my biggest issue usually with doing that type of a stream live is that the kind of the connection over into Unreal can be the hardest part of it, right? And while I'm streaming on the same computer that I'm working on, which is not ideal. And so I really feel like if I do that, it's going to absolutely annihilate the stream and all that stuff. It's going to be really hard. I was planning to have a new computer this year, so that would have been maybe more of a realistic thing because I have 2 machines that I could use. But there are some personal expenses. You know, I'm going to be moving into a home at some point in the near future. And so that is not so much in the cards, I think, currently. So while I would like to do that, I guess, and that would be certainly a cool thing to suggest and put in there just so I'm thinking about it. Cause, the more suggestions there are in the Discord, obviously the more I'm kind of considering those things as I'm thinking through things. But it's a possibility that we could do that on the stream. I'm just not sure how well everything would handle that. So yeah, I'm not a huge Unreal Engine user anyways. So for me, that's a little bit I hesitate to go too far in that direction because I don't have a lot of good answers for stuff, and I don't really know how to optimize things in Unreal. It's just not my world at all. It never has been. So I've learned some stuff about it, but I'm definitely very much at a beginner kind of surface level in Unreal. So, yeah, that's a great question. I don't think I have done any on those, but yeah, that's kind of my 2 cents on that. Oh, another thing. If ever there's any issues with the stream or anything like that, sound is bad or you can't hear me or whatever, you always feel free to drop that in the chat too. I can't hear what the stream sounds like, so or looks like or anything like that. So if you're running into issues, always please let me know. So anyways, yeah, I think that's all for that type of thing. Please feel free to ask questions. In the chat. That's the whole point here. Is to have a conversation and to kind of go back and forth. And that's about it. Let's, I guess, dive into Houdini and make some clouds. Let's do it. All right. So, sorry, I was like smacking my hand into my base of my monitor here. Okay, let's take a look at something here and get rolling. So, as always, we'll throw down a geometry node. Hey, from Thailand. Wow. Well, welcome. Welcome, Podcast Fiction. Glad to have you. Thanks for watching from all the way around the world. That's crazy. Okay. Whoop. I'm getting blown up here. What's going on? Thought I turned on my do not disturb. There we go. Thank you. All right. So let's call this, yeah, let's call this clouds. That should be a good idea because I might actually render this and we might make a lightning. So let's do that. Okay. So the one thing that I like to, if you come in here, your tab menu and search for cloud. Hold on 1 second. I'm just looking at something here under my preferences. I feel like my user interface is a little on the small side. No, I think it's okay. I think that's fine. I scaled it up a little. So if we do type in cloud, we can see that there are some kind of, yes, I am in the US. Sorry, my thing is coming up there. Yes, I am from the US. I live right near Niagara Falls, which is kind of a famous waterfall in North America, right? Kind of in border of US and Canada. So that's where I live. All right, so let's type in cloud here. And there's a bunch of these new cloud nodes that got put in here. Some of these were here before, but there's like these like cloud shape generate, cloud adjust density profile, shape from all these things here. So what I think is kind of a cool workflow, and I think we've talked about this a little bit before, is use the cloud shape generate. And this is kind of a neat node because it works within the with these kind of polygons, or I'm sorry, sphere primitives to make the clouds, right? So it generates the shapes out of these spheres. So you can see here we've got spheres in the viewport, and we can kind of control some of the shape of our cloud. So I think this is a pretty small cloud. This is really only a couple meters. Yeah, it's only really about a meter across. So let's make it a little bit bigger. I think maybe like 10 meters feels a little better maybe, but let's see here. Let's do 6 here. So you've got these length and width sliders that we can play with. So let's kind of mess around with that a little bit. Let's do that maybe. How's that looking? Let's see here. Yeah, maybe that's good. All right, and then what we'll do here is I'm going to just up the point separation a little bit, just so we don't have so many small little spheres that are not really adding much to this. So we can adjust the point separation. That's going to make the particles be larger and a bit more separated. And there's a couple other things that we can do as well. So there's all of these kind of things that we can basically adjust and play with and stuff like that. So I feel like, nope, sorry, there's a couple different things here. Yep. So I think we're just going to stick with the standard shape. Yeah, I think so. Mediocris? I don't know how to say those words. These are different types of clouds. I don't know. Somebody figured all this out. It's pretty crazy. But anyways, so one cool thing that you can kind of do is you can add some of this spread to it. You can also add this displacement, and that's going to make it go up a bit more. So we could do something like this to make them a little bit more billowy and puffy maybe. We can also change the number of iterations that these particles are kind of displaced upwards. So there's a lot that you can play with here. You can kind of make these your own, kind of adjust however you might want them. But this is going to kind of exist as the base shape for our clouds. So let's do maybe like 0.3. And you'll see here too that as this point separation changes, that's going to adjust how the shape is going to look a little bit as well, because these points are being generated kind of on top of each other, right? And so they're being kind of created as like points from the surface of the previous sphere, basically, or spheres on spheres, basically. So so that's kind of cool, an interesting idea. We can also change the shape of these, right? We can adjust what the minimum scale is here and the maximum, so we can get some different looks out of this. So yeah, you can kind of play with that as desired, and you can also like adjust it like that. Like, yeah, that's kind of cool actually. Maybe we do a little bit like that, get a little more randomness here. Great. So there's maybe our default cloud shape here. And there's a few things that you could do now from this as well. So you could take cloud and do cloud shape replicate. Now this can get pretty heavy, so you have to be a bit careful with this. I'm going to turn this up just a little bit so it doesn't get too crazy on us. So you can see here that this is going to take kind of this base shape and then replicate on top of that sort of. And we can kind of play around with this, and you can see that we're sort of, replicating on top of this point cloud and making a bit more surface detail, I guess, in some ways. It really is sort of up to you how you might want to make this and have it work for you. But I don't think that I'm going to do this per se, because it just feels like it adds way too many points in my case, and it just doesn't feel like super worth it in this case. We could always go back here and change the point separation up a bit more like this. And maybe that's our base shape. Something like that, maybe. And then if we do the cloud shape replicate, it's going to make a little bit more detail from that. So you can see how this would be useful. You just kind of have to make, you know, hey, Revo, welcome to the stream. So you have to just kind of make a judgment for yourself on shapes and things like that you're going to want to use. I think I can get away with just being like this. So let's just do something here. I kind of like that. That's kind of neat. Hello, Houdini time. That's interesting. It's an interesting YouTube. Wait, is that Paul? Or no, not Paul. Gosh, I feel like I know that name. Anyways, hello there. Welcome, Houdini time. Oh, anyways, sorry, I'm getting distracted now. Yes. So yeah, let's stick with this. I think this is kind of a cool shape. It's got an interesting thing going on here. And then we're going to do a VDB from particles. Sorry. Yeah. Just making sure I'm grabbing the right one. And we're going to be able to obviously make a VDB from these particles, right? And so instead of doing a surface, we're going to do a density, right? And so many Houdinis. Yeah, what's going on here? Everybody's Houdini. What's going on? So we've got that. We could also adjust this point radius scale a little bit here just to make sure everything is like being contained. Maybe like 1.1 just to give it a little extra scale. And the voxel size could certainly come down a little bit. So we could do 0.5, maybe something like that. Yeah, that's looking pretty good. Let's see here. Yeah, there we go. Maybe something like that. And then cool. And then there's this really cool node that we can use to actually make some adjustments to these fog volumes and maybe make it work a little bit better for our clouds. So we can also do cloud adjust density profile. It's a really long name. But this one's really neat because you can visualize the density here, right? And here's our cloud density, right? As like a 2D grid. And you can see here that we can do things like edge thickness, right? So we can adjust that, the edge thickness, and then change the edge density and the internal density. So here with this, you can see we're changing the edge thickness, and this is visualizing our density of these clouds, right? So this will make the outside of the cloud be a bit denser and the inside be a little less dense. So we can kind of play around with that, right? We could sort of do something like that. Give the internal, we could have the internal density go really high. We don't have to do that. But you can see here by default, it has this sort of fall off. So if we wanted to do the edge density here, we could have, we could give it a little bit more density that way. Give it some extra fall off. There's a lot of different things that we could do here to make this a little bit more interesting. So let's do that. We'll go back to visualize density. And you can see here now that this sort of like solidifies it a little bit on the edges, right? It kind of gives it this nicer. Yes, the adjust density profile is really cool because it doesn't just have to work for clouds. I think you could do it with any VDB, but it's a really nice little like tool to be able to get in there and actually mess around with some of this stuff. So that's kind of a nice, it's kind of a nice prep stage for getting to work with volumes and these cloud type nodes. So then we could do the cloud billowy noise next and start getting into some actual billowy noise and starting to adjust this. So let's override this look to be the ambient occlusion, right? So we can do that. And let's kind of mess around with this a little bit. Let's see what we can get up to here. We might need to get the element size down a little bit just to create a little bit better noise. One thing that I think is really nice is adding some of these whorly details in. That starts to really like noise up the cloud nicely. But we're going to play around with some different things here and get this sort of, in a better state for us here. So let's see. We'll leave that up. Let's see here. Let's set this back maybe a little bit there. No, that's fine. And yeah, so you could see obviously how this will affect some of those, the density of those edges and things like that. But anyways, actually I'm going to turn the edge fall off back to that, and edge thickness. Great. All right. So we can do two different visualizations of this. We can kind of see it as a reversed occlusion or an ambient occlusion. So there is that. And we can do a bunch of different things here, right? So we can change these element sizes, the erosion, how much we're blending in these sort of whorly details, which is just another type of noise, right? Is whorly noise. So we can look at this and, maybe we do a couple different, we can kind of look at some different things here and play around with this and see what we can get into. But I'm still seeing that there's some pretty sort of strong spherical shapes here that aren't really going away too good yet. So let's start sort of looking at that and maybe knocking those down a little bit, messing around with them. I'm actually going to turn off the whorly details for a second here. Maybe what we do is just kind of play around with these general details first. Give ourselves some of these large scale feature, these sort of not larger scale, but fairly large scale kind of billows and things like that. And then we can go back maybe and add a little bit more noise and kind of knock, add on some more details from there. So just sort of look at what's going on here. Actually, I wonder if I do this. Yep. So that's what it is normally. And then if we go up to 1, for example, that's what we're kind of getting into with this billowy noise. I think maybe something like that is starting to look pretty nice. Let's see here. Yeah. Just going to kind of play around with this a little bit, see what we get into. Yeah, I think we'll maybe stick right there. Get some of that. And then let's do another cloud billowy noise here and see if we can't add in some of those whorly details and see what that, yeah, see that's going to kind of chunk away and eat away at this a bit. So let's just see what this is doing for us here. Let's do like 1.5 on that. Yeah, that's kind of cool. Getting some neat little billows and things like that. We can do a lot to make this sort of work the way we want it to, right? But obviously this isn't the bulk of what we want to do here. But there's a few different ideas that you can use when you're doing this. You could add nodes like this. You can also take a node and you can do iterations on it. So we can do, a few iterations of that noise and kind of change the way it looks. So let's do this and this. We'll just kind of look at these against each other and see the difference, since that'll be a little easier than turning it on and off. So let's just do a switch here, and that'll allow us to kind of visualize these against each other. So there's just one iteration, right? And then here, just separate these apart. We'll say 1. And then this one's going to be 3 iter. Okay, so now you can sort of see what we're looking at here. So this is one iteration, and this over here, when it goes through, is going to be the 3 iterations. So we can sort of see how we're allowing some of these pieces to be broken up, right? And really, I think what you're starting to see here, in this case here specifically, with these, we're getting this nice we're getting some voids here, but if we want that to billow in some different ways, we could switch it here, and this will actually kind of, this can actually fill it in differently and make, this will just kind of change the way that your noise is looking, right? When you're doing that. In this case, you might want to up the element size a little bit maybe, and that might make the noise a bit larger because you're iterating on it a few times. Another thing that you can do is you can actually advect this noise as well. If you have a question about Vex and VOP, please feel free to put it in the chat. Maybe when we get to the next little break here, we could kind of talk about that for a second. But yeah, feel free. Drop a question in the chat about Vex and VOP. That's cool. So what we can do here is, obviously we have those iterations. So that's kind of interesting. Like so. So we could do 2 iterations, and that'll kind of, yeah, you can see it. It'll go back along and kind of change how much evolution kind of is being put into that noise pattern. I actually kind of like the 2, to be honest. We can also do advection. So we can advect the noise kind of through the field and get some different movement there. So turning that on and off, just going to get a little bit of movement kind of added into it. So it's kind of neat. And so also with our noise generation, we can have it generate noises underneath as well. So like this is multiple noises for each iteration, right? So you can have kind of these levels on top of each other of noise and advection, things like that. And so this is the 1 iteration with some advection and processing and things like that. And then this is the 2 iteration. Let's see what that looks like. Yeah. So there's the 3 iteration with noise passes and advecting it. So there's a lot of different things that you can do there, and you can change. I think this is the attenuation for each step. If you want some more details on this, there's actually, I don't know if they published those or not publicly, but our interns internally did some really cool kind of walkthroughs of these nodes. So if you're curious about them, I think there's some cool videos out there, but there's also stuff on the content library that you can jump into and take a look at. Get a kind of a sense for that. So anyways, there's a lot of details in here that you can kind of play around with. So I do really recommend to just kind of get in there and start messing around with some stuff. You shouldn't really be able to do anything too crazy as long as your VDB settings aren't too low for your voxel size. So you can see here I have like 2 million voxels, and everything's pretty responsive in the viewport and things like that. Your mileage may vary, but that's kind of the idea. So, hey Sam, welcome to the stream. Yeah, Maitland. Yeah, exactly. Vex and VOP, the hard Houdini, right? Yeah, it is a big part of it. So Houdini time. We'll get to that in a second, and we'll maybe talk about that shortly. So let's see here. Yeah, I think this is starting to kind of make an interesting looking cloud for us. I like sort of where this is going. We could look at the 1 iteration as well. No, I think this is more interesting. I think this looks way more realistic from a cloud standpoint. I'm not an expert, but feels good to me. Okay. So let me think here. What are we going to do next? All right. Let's put pause on this because I do want to answer the question here about VOP and Vex. So Houdini time was just saying, I'm starting to learn about VOP and Vex and Houdini, but I can do just a simple operation if I want to improve my VOP and Vex skill. Do you think I should focus on one or learn both at the same time? Well, so to think of them as 2 completely separate things, I think does yourself a slight disservice, because VOPs and Vex are actually pretty closely tied together. VOPs are kind of the visual language of Vex in some ways, because when you do a VOP network, you're out. In fact, it might be the other direction where Vex is the text-based of VOPs. But anyways, I don't know the exact technical way that works, but this is how I think of it, is that you can do a VOP network and have, here, we'll just do another little thing here, right? We'll just do this randomly, right? So let's do this. We'll do, let's just do a grid, and let's just look at this for a quick second. So if I want to do, so I kind of use these two things differently, right? So if I do a point VOP, and if I want to do noise, most of the time I'm going to use a VOP. If I want to use some sort of really specific for each loop or something really granular that I want to get into, I'll probably use Vex. Like for example, if I wanted to, let's just look at a point wrangle as well and just kind of look at this, right? So you can do the same, almost the exact same thing with either of these. There are some, both exactly, Graham. They're both important, right? But to not just completely separate them, I think is important because, for example, in a point VOP here, if I wanted to do some noise, right? So let's just say I did a noise of some sort. Let's just do like a turbulent noise or something, right? And we do the position into P, and that starts outputting our noise. And then let's say we put the noise into CD, right? And then come back over here and look at it. There we go. We've got some noise. In this case, it's just a grayscale value. It is what it is. We could also turn this into 3D noise, and then we're going to get colors that are added there. And we can change, this. We can change the frequency, right? We can make it, whatever. This is obviously just a very silly example, pretty much. But, this is, let's see here. There we go. Just needs to get really fine grain there, but you can see we've got some noise coming through. And if let's just up this a little bit, so it's like 100 by 100, right? So there's our noise on that. You could do the same thing in point wrangle, and do like at CD equals, some sort of a noise, right? But these can be a bit tricky because there can be a lot of arguments that come after the function that can cause the noise to get really complicated in Vex. Now, not to say you can't do it. I mean, people do it and it's great. I think Vex tends to be a little faster if you have really big processes or whatever. But let's just do this noise, and then we can do V at P, and this should just give us a noise here, and we can just kind of, there you go. We've got some colored noise here, right? And in fact, I should be putting V at CD just to make sure we're being specific here. But that's my whole code that I had to write to make some noise. Now, there's other noise functions and things like that, but that's not really what I think a wrangle is best for. Wrangles are really good for making quick attributes with maybe some custom math that you want to do quickly. VOPs are really nice for kind of prototyping things too. So they really each have their own power and use. So another really interesting thing that you may have not done is you can do view Vex code from this, and this spits out a whole thing of the code that's actually happening with this network. So here's our Vex code that would be running. So you can see how much longer this code is, right? That is what you're doing inside of that VOP network. So that's why there's, I think, a little bit more overhead in a VOP network, because there's a bit more yes, that's a great statement. Yep. If you're more comfortable with Maitland just added this, if you're more comfortable with the code, then you can get a lot done with Vex really quick. But you need to know what's going on with the attributes exactly. You can do stuff really quickly, really fast. If you're pretty comfortable with this, I would definitely say you should learn both, because they each have their pros and cons. Like doing for loops in VOPs is a bit of a headache. Doing or like a for each loop in VOPs is a bit of a headache. Doing a for each loop in Vex and a wrangle from the VOPs. Yeah. But yeah, so it's just kind of a yes, exactly. That's a great point. If you look at these inputs and outputs, those are all of your like attributes that are, they kind of give you the global ones here that are made at all times. And you can actually reference these in Vex as well. So if you do @F frame, that'll give you an attribute. So these are all the attributes here. So something to keep in mind, if you are interested in getting more into that, I did do Joy of Vex series a while ago. Let me see if I can really quickly grab that. It's on the CG wiki. I know he linked to it. So let's see here. There it is, Joy of Vex. So there you go. So this is the link to the playlist, and there you go. You might, hopefully that'll come up on the stream just fine. Or at least you can copy and paste that into your browser and get to it. But CG Wiki, Joy Effect, Vex, it's under long form. He's got all of the actual stuff here. And then I did a little playlist of myself going through it. So that might be helpful to you as well. And so that's just Vex, but certainly VOPS is a good thing to have as well. So hopefully that answers some of your question. And yeah, hopefully I think that's where we'll end that little sidetrack. But yeah, it's a great question, and one that comes up quite often. So thanks for bringing up the question. Appreciate it. All right, let's get back to some clouds and see what we can get up to here. So we have sort of our cloud. Obviously, we can tweak this a bit more if we wanted to. We could, mess with the noise all day and get it just perfect, but I'm pretty happy with where this is. I'm not going to belabor the point of saying, oh, we got to do this and that. There are some cool things too in this cloud shape, just as a note. It does flatten the bottom of these here, which is kind of neat. You can also turn that off and then it won't flatten the bottom and you get kind of a more rounded bottom to it. So, whatever floats your boat, but I think I'm gonna do the flat bottom just to give that kind of cool, like, I don't know. It feels like those like Toy Story clouds or something. I always like that. But anyways, okay, so we've got this cloud billowing noise. This is a density VDB. It's a float, VDB, and that's what our output is right now. So what I was thinking, and what I kind of feel is a pretty good way of going about this, is if we want to do some lightning inside of this, for example, we need to have some points inside of this, right? And then connect those with, some sort of polygon lines, polylines or polygons, whatever we want to look at. So I was kind of thinking about what's the best way of going about doing this. And what I kind of feel like is a pretty good way of doing it is actually using tetrahedrons to connect the inside of this, because we want kind of all these random lines going through the inside of it in kind of 3D space, but we want to be able to kind of find random paths through that. And so that was my idea. So that's what I'm going to try. That's what I'm going to do. And we're going to play around with that. And we can maybe look at some other ideas in a little bit, but that's going to be my thought first. And we'll kind of go down that. So let's do this. We'll make a null here and just say out cloud volume, color that green. And let's go up here. I'll just put this on. I'll say, call this rabbit hole. Vex. And let's do this. I'm going to call this GeoClouds. Then let's do, it does have to recook because I renamed it. That is something I wish could change. Maybe that should be an RFE. Let's do Geo Lightning. And the reason I'm doing these in separate is because I am actually going to try to bring this over into Solaris and do a little rendering with it. I don't know how it's going to work out. I haven't tried that before, but why not? It's not a crazy huge simulation, and we should be able to do some stuff with it. Okay, so we've got our lightning here. Let's go inside. Let's do our object merge to bring those things across. Let's do GeoClouds, out cloud volume. There we go. So we'll just say get cloud. And I always do my object merges as red, so I know where those are. And let's do this. Let's do a convert VDB. And let's take this and change it from a fog to an SDF. So now we have this SDF volume here. And if you're not familiar with SDF, it's really just looking at, it's creating a volume that tells you how far you are from the surface of an object, right? And so what we're actually doing here, which is a little different, is that, and you're going to see this probably disappear in a second, I think. Yeah, it gets kind of crunchy there. So basically, when the density is below this value is kind of where it's creating this surface. At least that's kind of the way I always think about it. So you can see as we go up here, it's going to kind of go out to the outer reaches of this edge that's happening here. And we're going to have this surface up at the really kind of the very leading edge of where that volume is. And if we go down a bit, it's going to try to find where, where the density is crossing 0.0983, right? I don't think we can go above 1, can we? We can, actually. So then there is no place where it goes over 2. This is going to get tricky because 1 is full density. So it's like once it hits full density, that's kind of what it's seeing as the surface. By default, this is at 0.5. So once it gets to half of its full density, yeah, no problem, Houdini time, glad to help. Once it gets past half the density, half between 0 and, once it hits 0.5, that's where it's kind of seeing the surface. So that's what we're doing here with this SDF. And then what I kind of thought we might do is just do an SDF. There's a few different, if you just type in SDF, you get a few of these. And what I want to do is reshape SDF. And what we can use this for is doing this dilate operation. So we can go maybe by 1, when we say offset, when we're dilating it, we're making it bigger. So we can do 1 or 2 voxels and just kind of push it out a little bit just to make sure that we're getting a nice boundary there. And it's a little hard to see here because you can't really see this VDB. So what you might want to do here is do a convert VDB again and just see what this looks like when it goes to polygons, right? So this is a polygon surface. We can turn up the adaptivity just so we can kind of get rid of some of these, just the amount of, polys and things like that. We don't need quite that many. And if we turn this on to the template mode and go here, we can sort of see where that surface is. It's a little hard to visualize because we're trying to visualize like wireframes and volumes at the same time. Actually, I think probably 1 is going to be better there. And that's conforming pretty well to the surface of that cloud. So we've got a nice surface now mesh that's matching back to that cloud. And that should give us some good, we can use that outer surface to kind of make some interesting stuff happen inside of it. So what I'm going to do here is I'm going to do a remesh. And let's let that go. Those are pretty good sized polygons. I can actually probably make it a little bigger. Let's see how that looks. Yeah, that's probably good. Maybe we'll smooth this a little more. 0.4 and 0.4 maybe, or like 0.2. Just kind of split the difference on that. Yep. Something like that looks pretty good. Okay, so Houdini time just had one more question here. So to be good at Vex, you have to be good at coding too. Yeah, I mean, I have to say that I've never been a programmer before. I learned Vex as probably one of my first languages. I knew a little bit of expression script in After Effects, but just enough to be dangerous. And yeah, that was about it. I didn't really know programming, didn't know Python, didn't know anything like that. So Vex really was kind of the entry point to me. And I think if you go through some of these, like if you mess around with VOPs, that's kind of more of your playground, kind of where you can do things quick and dirty and just kind of see what wires into what. But if you want to then start playing around with the Vex, I think something like Joy of Vex is a great way to get into that because we sort of start you from the beginning and work up to some more interesting things. So it kind of teaches you how to think as a programmer and a coder. And all of Houdini is a visual programming language anyways. So, you already have that mentality if you're starting to get comfortable in Houdini. So I wouldn't be too scared of it and like say you have to be a programmer already. Obviously that would help, but it's its own programming language. So you do have some nuances that you'd have to learn anyways. So hopefully that's a good answer or helps you a little there. Cool. Okay, so we've got these polygons here, and maybe we do maybe 0.25. Just want to smooth it out a little more, maybe. Yeah, it does. It can be tricky from that. It does look like those languages, but it is not. All right, so we have this remesh. Let's then do, I think here we can do a tet conform. And it looks like with this tet conform, literally nothing looks like it's happened, like nothing's happened. But its looks can be deceiving sometimes. So if we go into wireframe mode, and I'm going to switch my background so you can see this because this is a little tough to see in this mode. But if we do this here, you can see from this being just our remesh to this, suddenly we have a lot of stuff going on inside here. So we've got all these tetrahedron. These are kind of 3D shapes that are they're basically like 3D polygons, right? A tetrahedron is a type of like platonic primitive, and so it's these kind of I think they're like pyramid shaped, all of them. It's really hard to see them, but I think they're like kind of all these pyramid shaped geometries, and we use them for several different things. You can use them for doing jiggly deformations in like vellum. You can use them for assigning weights to characters. But in this case, we're going to use this to kind of find paths through this geometry. And so this is really just kind of a stopover point. We're not going to use this truly as it is, but we're going to sort of go from here. And if you look here, you can see that there's a lot of these points inside as well they're kind of all existing inside of here. There are some clustered points here because this is kind of really convex and concave at the same time. There's a lot of both concave and convex shapes happening here. They kind of get bunched up in certain places when they're being made. I'm not sure if there's a good way to get rid of that. If somebody knows, I'd love to hear that. I think you might be able to scale those out a little bit better, but I was playing around with it a little before and I was like, it's fine. We can just fuse those together in a couple steps. But anyways, that allows you to kind of see what's going on inside of this shape a little bit. And I think if we do a convert line after this, this will convert all of those shapes into lines. And sorry for the blindingly probably bright white that's going on there. But now these are all actual just points with polywires between them, right? And so if we looked at just a little section of this, let's just kind of look at this here. We should be able to see that each of these polywires is their own, piece now. So like that's one, things like that. And they're obviously all connected with individual points here. So this is what we can then use to sort of go through the inside of this and make some interesting shapes out of it. So let's sure, Maitland, what do you got? Curious to hear. I'll give you a second to type up your response. Love to hear it. So okay. I'll let you. Yes. Yep. Points or polys. Yep. You can do it all with vex. Yep. Because exactly. Yep. That's very true. You don't have to do a geometry for loop, and you can do a lot of for eaches, or not even have to do a for each. You can just, when you do vex, it just loops over all of your points. So it's a really nice. It's very nice from that standpoint. It's very optimized for huge amounts of data, and technically VOPS is as well. It's similar to vex. It's just a visual kind of programming version of it. So yeah, very, very nice. That's a great point. very optimized for huge amounts of data being worked through it. Okay, cool. So we have these points and polygons here that we're going to work with. And if you've ever used, I think it's find shortest path, this is a really cool node that we can then use. I don't know why I started this off like this. Oops, I'm going to move this over so it's in a line. I think I will use one of these in a second. So we've got these find shortest paths, right? And this is angry at us because we've no start points specified and no endpoints. So you might be thinking, well, okay, what are we going to do for our start and our endpoints? Well, one thing that's kind of neat is that this tet conform actually does interior points and surface points. So we could take that and sort of take our start points as our interior points and our endpoints as our surface points and get something interesting. But did we get anything interesting? Not so much. Looks kind of like a weird puffy, I don't know, weird spiky something. I don't know, weird little animal or something. So this obviously isn't exactly what we want. And the way to think about this find shortest path, which is really cool, you can have it work really on any geometry that's connected together. You could do it on a surface. You could do it in this case with a bunch of points and lines that are connected together. So when you give it the start points, you can see here there's different output paths that we can do, and we can do from each start to any end, right? So in this case, we're going from each start point, which is all of the interior points, to any end surface. So you can imagine that most of these are just going like a short distance to the surface, and that's not super exciting. One thing that we can do though, is we can actually give a cost associated with each point, for example. We can also do that with the primitive cost attributes as well. You could do that either way. In this case, I think it's better to do it as a point cost. So let's just kind of go back here and let's look at this. What we can actually do is give that shortest path a cost depending on which direction it's going to go, and allow it to kind of find its cheapest path to the surface or to the endpoint. So we don't have to go in a perfectly straight line. A lot of times we can give it some incentive to move in different directions. Hello. Wow, there is no hope. That sounds very unhopeful, but hi, welcome to the stream. Nice to have you. Anyways, so let's do that real quick. Let's add this cost attribute, and this is going to give us a cool little thing to help us with here. So let's do an attribute adjust float. Just for kicks, we'll use this, and we'll do a noise, and we will call this cost. Let's see, we'll call it point cost. Let's do that. And down here, we're going to grab the point cost attribute and look for point cost like that. So right now we don't really have too much happening here. We may have, let's see. No, we probably aren't doing too much in this case. So we've got noise. Let's visualize what's going on here. So we're creating these point costs across our across all of these values, right? And so what we want to do is let's maybe make this a bit noisier. Oh, cool. Houdini time. welcome. It's always nice to know people's connections and things like that. Cool. So we're still running into some problems here that we're kind of not able to, well, let's see here. Let's also give this a bit higher cost for some of these. So these are going to be really high cost, and then we'll get some low cost. So we're running into this visualization issue here where everything went red. So let's do this. Let's go to the eye, and I think if you control click on this, it'll bring up the visualizer, and we can set the min and max to auto so that it'll automatically find our high and low point. And so there we go. We've got that. Let's see if that changed anything here. No, it doesn't look like it. I still think that we're running into the problem of them being too, there's too many options for the endpoint, and it's really no reason for it to go somewhere else. So let's reduce the number of interior points and surface points and start to see if we can't get something a bit more interesting. So we have these groups here at our tet conform stage, right? We've got interior points and we've got surface points. So let's add a group node and get in here. And what we can do is we can select one of these that we have already. Let's do interior points first. And this will be a point group. And let's turn this off and change our visualization here. Oops. And we could say maybe intersect with existing. Okay, so if we look at that, it might be a little tough to see on your screen, but there's a bunch of orange dots here. Let me see. Let me go D. There we go. Hopefully that's a little easier for you to see. There's a bunch of point markers here, and these are all of the interior points, right? Oh, another thing I want to do, I want to fuse these together. So let's do, let's hold down Shift here and click up, and let's add a fuse in here. And this will allow us to join some of these like clustered, these like highly clustered little areas. So let's just, I think if we turn this up a little bit, we'll see this start to snap some of those together. And yeah, that's probably good. Something like that, maybe. Just a little bit less density in those areas. Maybe we'll do 0.2 just to make this nice and even. Okay, should be good there. Now I've got a little bit more of a uniform amount through there. And so let's take this group. What we can do is we can do keep by random chance. And so what we're doing here is we're actually going to be intersecting with the existing, right? So that means that if it exists in this group that we're creating here and the incoming group, in the selection we're making here and the incoming group, they will stay in the group basically. And so we can turn this percentage down, and now we're just going to have a few points in here. So let's do just a few. Maybe, how many are we doing here? Let's see. 72. Is that really how many we've got here? All right. Let's maybe do like very few. Let's do 1%. We'll just have a few start points here that are going to be throughout there. And then we're converting them to a line still. We're adding this point cost here. Let's maybe make this a little bigger. Let's maybe say 0.5. And yeah, let's leave that. And now let's see the find shortest path and see what we can get up to here. And so path cost, PT cost. Yep. Okay, cool. So let's see here. What if we change this around a little bit? We can see that we are getting some different looks here. So if we turn this, let's just say we have the values to 0. This is what it looks like without it, right? And the element size we can change to just 1. Now if we start adding a little bit of this in, we'll see that this is starting to push these points around in some different directions. It's not going to really do too much still because we have so many edge or so many outside points that it can go to. So let's fix that now. Let's do the exterior points as well. So let's do this and this. Point cost. Let's leave that at 10 maybe. And we'll do this at 0.5. Great. Okay. So let's now do the surface points. Sorry, not exterior points. So surface points. And you can see already we're starting to get something sort of interesting going on here. Let's take a look at this. And we can see these are our surface points that we're trying to get to. Now, what I'm going to do is actually try to match these together because we can do something really interesting here. So for our interior points, we have 17 points selected. This is a little bit manual. I was trying to think of a good way of doing this, and I couldn't really think of like the most, what am I trying to say here? If there was a good way of kind of figuring out, of matching the number of points in each group. So what I did is just kind of tweak this by hand and just went down until we got to 17. And you can see that. It might be hard to see, but we have 17 points selected down here. Yeah, I think you can probably see that. So now if we have 17 in both of these, we have 17 points selected here. We have 17 points selected here. That we can actually change the mode that we're going to use. So we'll take a look at this in a second here. But now if we do our find shortest path, we can see that there's definitely some more interesting stuff happening here. We can tweak our point costs, and this will give us all sorts of different, looking things going on here. We can kind of play around with this. As we noise it up, it's going to change the look of it. Changing this value is going to change the cost. In fact, I think having the stronger this gets, it kind of stops working too much. Just a little bit is fine. You could probably do it at like 5 or something like that. It doesn't have to be all the way up to 10. But anyways, those are kind of the two main catalysts here for getting something interesting going. But there is one more thing I think we can do that'll help this. If we look at the interior points here, we have some of these that aren't so interior. They're kind of close to the surface, actually, like this point right here. If we look at this one, if we go inside here, this one's pretty close to the surface. I think it's only one line away. So there's not really going to be too much interesting going on there. So if you remember, we had our SDF up here earlier, and I'm going to hit W to go out of wireframe mode. And this is telling this SDF actually stores within it the distance inside of this volume. So what we do need to kind of adjust here is we're going to kind of extrapolate these surfaces, and because by default there's only so far that the surface goes away before it kind of hits its maximum value. In this case, usually it's like three voxels, and then it hits whatever value it's at that level. So we can see that in a second, but we're going to need to expand this a little bit. And what we can do to make that expand a little bit more is use an SDF activate. And what this will do, we're going to wire this in separately because we want to use this as a separate thing. What this is going to do is we can adjust how many these, what they call half-width voxels. And this, we can go like this, and you can see that just this bounding box is changing. Nothing inside is actually changing. And what I'm going to do, instead of doing it that way, is I'm going to use world space units. So you can see right here, we're at 0.1 meters right now. And so what I'm going to do is, instead of just having it be at 0.1 meters, that's not very big. You can see here we've got about, probably at least 5 meters to the inside of this. So let's start out with 3. Going to give it a second because it's going to get bigger. It's going to have a lot more voxels to it. And if we do W, though, you'll see that this has changed a little bit how it's visualized. So this is what it looked like before. And now we're expanding those kind of edge, like how far from that surface the data is being stored for the distance to the surface. So before we were only doing it 0.1 meters. Now we're doing it 3 meters in every direction. We can go a little further than that, but let's just start here and we'll use this to our advantage. So I think this is a case where I would use VOPs. So I'm going to just do a point VOP here. Oops, if I can type. And what point? Let's see here. Let's do it at this. Convert line, since we've got everything fused. We'll wire this in here. We'll just say add a null in here so we know what's going on over here. We'll call this Cloud SDF. And that's going to go into there. Okay. So we'll wire this in a second, but for right now, we'll just stick here. We'll dive inside of that. And what we're going to do is we're going to do a volume sample. We're going to look at the primitive numbers. Fine. There's only going to be one volume primitive. We're going to go to the second input for this. And we're going to sample this at any position that a point exists in our vex. So every point is going to sample where it is in that SDF field and grab a value from that. And so now we're going to get the SDF value from that specific spot. And let's do a bind export. This is going to save this as an attribute. And we can just do this. And we can we'll call this just surf dist. It's going to be a float. And if we look at that, we should see that we have our surface distance here now. And we can see that we're going to go anywhere from, well, negative is going to be inside, positive is going to be outside. There may be a few that are going to exist outside, but just barely. So they're just barely outside of the surface. They're going to go down, and those are all the surface basically points. And then they're going to quickly start going inside and get deeper and deeper. And we're going to go down to negative 2.7 down here. And so let's visualize that and see what it is that we're working with here. Okay, so let's click on the little eye here. We're going to visualize our surface distance, and I'm going to control click on that just so we can do an auto here and see sort of the the distance that's going on here. And there we have our maximum at value, which is basically 0 at the surface. And then we have our minimum, which is in this blue area in the middle here. I actually might change this a little bit. I feel like I want some more tetrahedron inside of there. I feel like it's a little sparse. So let's see. Can we do that a little smaller? Can we get some more in there? There we go. That's probably a little better. Just going to go down a little bit in scale. That should give us some more detail inside of there. Well, let's see if we do this any different, if this is going to change. Yeah. So this, let's just look at this here. This will kind of show you what I was kind of explaining, is that for this, in this case, we've kind of changed this VDB activation. You can actually see that there's a little it's a little hard to see on my screen maybe, but there is actually a cavity inside of here. As I kind of, that cavity is where it stops calculating on the inside as well. So here you can see that cavity in the actual geometry attribute. So if we do surface distance like this and go, sort it by the minimum, all 0.95 is going to be the minimum there inside. And then it goes down like so. And as we change this VDB activate to higher half width, it's going to go tighter and tighter to the middle where it's still calculating values in there. So now we're automatically, we're scaling this, right? So that's the lowest values in blue. It's not actually telling us what the value is, just that that's the lowest value. So now the lowest value is kind of scaling inwards there. And we can go to 3. We'll see that even kind of ramp down a little bit more. And I think if we go further, it's going to just kind of stop changing because there is no further that you can go inside of it. It's all the way calculated in there. So there's no reason to go kind of past 3, I would say, in this instance. You're just creating more voxels, and kind of maybe even 2.5 might be all you need. 3 is probably fine. So you don't want to go too far and just kind of go, oh, whatever, we'll take as many voxels as we can, because there's really a point at which it's not going to calculate distances any further inside of there. It just kind of collapses on itself. Cool. So this is now something that we could actually use, this surface distance. So let's just say we came down here, and now we have this surface distance. Actually, we would want to probably put this up here. I wasn't thinking that through properly, because we want to use that before we make our groups. Let me just make sure that this will work fine. I think it will. Yep, looks like it is just fine. It's just putting it on those points, and this is all in the tetrahedron space, so no problem. We could have, I guess, changed the order of that. Whatever. It's kind of all irrelevant at this point. These can all sort of swap directions. We just need the attribute to be before the group. So we could have converted it to lines and then made the groups, but whatever. I'm just going to put it there. All right. So here, for the interior points, what we can do is we can say for the base group, let's turn this off actually for a second. For the base group, what we can do is we can actually write a little tiny like expression in there and have it limit the number, the distance to these interior points. So we can do at surf dist, I think is what I called that, right? Yep. At surf dist, and then we'll say it goes down to -2.5. We'll say less than -1 maybe. So we'll say less than -1. So now what you can hopefully see here, and I can maybe turn off that visualizer, so that might help it a little too. You can see that we've now limited it to those initial interior points being more kind of constrained to the middle. And again, we could do this even further and go down to -2. And now we just have those inside there. Those are going to be our start points basically. And then when we do by random chance, we can adjust this and get back to say 17 points like we had before. And now these are all kind of in the middle of our geometry here. And we come down to shortest path. We can see now we're getting maybe some more interesting values. We can adjust the element sizes here and have these kind of kick out some way more interesting shapes and do some cool things like that. So if we look at it sort of this way, we can see now we're getting some like bolts that are going in random sort of directions through there. We can also do the same thing with the surface points, right? We don't have to have those be just on the surface. Maybe instead we would want to sort of change this around a little bit. Maybe we'd want to take all the points across the whole, across the whole object, but only have it go out to not all the way to the surface. Maybe we want them to go to, the outer so much of the of this cloud. So since we have that attribute, we can say, let's call this. Let's just kind of change this a little bit. I think we can do surface points here. We can change the group name to be, maybe we'll just call this ends. Oops, if I can type. There we go, ends. So now we're starting with the surface points as our base group. And we can say, sorry, just thinking here. Okay, what we could do is say at, let's turn this off for a second here. Say at surf dist is greater than -1, maybe. Oh, let's do replace existing. There we go. That's what we want. So now this should be all the exterior points and none of the really close. Yeah, it's kind of hard to see. Let's see. Does that do any better? No. So this is going to just be the surface. And if we do -0.5, we should have even fewer ones at the surface, closer to the surface. So what we could do as well is say surf distance is less than 0 or less than 0.5. Oh, sorry, less than negative, maybe 0.25. That's going to bring them in a little bit. We'll just do 0.1. And then we can do and, which is going to combine them, say at surf dist is greater than, I don't know, 1.5 or -1.5 because we're inside. Negative means inside. So let's see how that works. -1. Just want to see if this is actually working. Maybe that won't work there. I thought that would work, but maybe not. Maybe making a little combination like that is not going to work. Just check and see if anything changes here. No. Okay. That's fine. We can also subtract. Just trying to think. I'm surprised that's not working. I thought that would. Okay. Could maybe do a group combine. Ends subtraction with, could I do, I wonder if I can do one here, at surf dist less than, no, sorry. Less than -1.5. Yeah, that works. Cool. I saw some of the points go away. There we go. So what we could do here is we can kind of give it a certain distance to the surface that it needs to be. So maybe we do something just really shallow at the edge like that. So these are going to be our ends, right? So maybe we even do 0.25, something like that. Cool. And maybe even more interestingly than doing this, we could just use this group combine and just do all of our stuff there. So let's change our path around a little bit here because we can do this differently. We can do interior points equals interior points. We can go back to this here. Let's see. Oh, sorry. Those are surface points. Surface points. There we go. And we can say less than that value. So that's great. And then subtraction with at surf dist is greater than, what did I say in this one? Or no, sorry. Let's just do that. Just copy that over. Sorry, now I'm confusing myself. Let me just start like with that. There we go. Why is it doing that? So we do greater than. Okay, sorry. I think I'm doing this the wrong way. Oh, I just made a. Oh, sorry. I got myself off track there. All right. We have our interior points. We have our surface points, but the surface points we need to be deeper. That's the problem. Just not thinking this through properly. Sorry. This makes sense. There's our ends. Let's take this and we'll just change this back to ends. Okay. And then we already have the surface distance 0.1. So this we'll say is less than 0.5 maybe. Okay. There we go. There's our little shell. Great. No problem. I would rather do that in one node, but it's fine. Basically, we're fine. Anyways, so we're going to use ends now in this last one. Sorry for that little roundabout there. I had to figure that out in my brain. Let's just call ends up here now. That's going to be our endpoints. And what we're going to probably want to do again, actually, is add another one of these down here just to do some randomness to it. So let's disable that. We'll say intersect with existing and keep by random chance. We'll just turn this up and kind of play around with this until we've got 17 there. Because I think that's how many we had in our interior points. 17 was what we had before. Sure, we could do more if we wanted to, but 17 looks good. Convert the line here. Then we have our find shortest paths. There we go. Cool. And now the one thing I really like about this output paths is you can actually do from each start to corresponding end. And so with this, it's actually going to match up each of those input and output, start and end points together and create something a bit more interesting there. So this is what those would look like without kind of anything at all, right? And when we add the noise in, get a bit more interesting shapes. They start sort of avoiding areas and things like that. And we get some really kind of cool, jittery, janky shapes like that. And if we, I think if we even reduce this a little more, we can add some more, should be able to add a little more detail into this as well. The only problem that just happened there is I think we added in more points. So this is the part that's not super procedural with this. And I would really like to figure out a better way of doing this, like having a set number of points in each group. Can't think of the exact way to do that. So in this case, we have 100 Yeah, no problem. Thanks for joining. Glad to have you on the stream. So let's turn this down. We'll do maybe we'll do 20 just so it's a nice round number. There we go. And then we'll do the same thing. Oh, look at that. There's already 151 points selected. Let's turn that down a little bit. We'll get 20 on that as well. Here we go. So now we should be good. Got those connections, and they should have a little more detail inside that they can kind of bounce around and do all that kind of stuff with. So pretty interesting. We're getting some cool stuff. Now, the only thing I don't like about that is they're on the surface. So I wonder if I couldn't give... Okay, what I'm going to do is do one more attribute adjust float. So we'll do this. Do this here. We'll set this to cost, and we'll visualize that as well. So let's grab that. Or sorry, it's point cost, not just cost. PT cost like that. And what we can do is we could add to the group. The group is surface points. You can see here we're now giving the outside its own surface value. In fact, if we do 100 here, you can see that it's now kind of made the outside its own kind of shade there. Actually, let me turn this off. You can hopefully see that a little better. And what I'm hoping this is going to do is deter it from going to the outside. Yes, it looks like it did. Perfect. Let's see if I turn this down. Yep, there you go. So what we need is just add a little bit of cost to that surface, and then it keeps those lines from going outside of the surface of that volume. So I want the lightning to be going inside of it. I don't want it to come out to the edge. That's not very realistic. So we want to keep it inside. So I'm going to just set this to like 5. And so we've now given a higher cost to that outer shell. And that's that. Why did the group names not show up in the drop-down menu? That is a great, great question. I wish I had a good answer for why. It very well could just be a bug. Just remember that every single one of these, especially these locked HDAs, are all created, not separately, but they're all created by different developers and stuff like that. So there may be something that changes in some code somewhere in Houdini that could propagate up and cause issues. So if you run into that, it might be a good idea to just, if you can replicate it every single time, it might be good to just send out a quick bug report and say, hey, like in this case, the attribute adjust float, I went to pull down the group for it, and there was no, there's no groups in the surface there, like nothing came up, or in the group thing there. So, it could be a nice thing to. Can use random selection node. Oh, duh. It's a labs node. Labs random selection. Nice. Yeah, no problem, Zach. Happy to help. No, it happens to me too all the time. So. Carlos, you're amazing. Thank you so much. That is exactly what you want. So, this is exactly what you would want. You would want to do, create a group from selected, and you could do a bunch of stuff with this, right? So we could very easily do that. So, let's see. Yeah. So anyways, you could do that quite easily and just keep a random number of the selections. So that's going to be the more procedural way of doing it. I'm actually curious. Random selection. What did they do in here? Yep, just a bunch of, pretty much just a bunch of wrangles. That's awesome. Cool. Yeah, pretty much just a bunch of wrangles that do exactly that. So, yeah, if you want to see other ways of maybe going about some of that stuff, there's nodes and you can poke around inside of those labs node. But yeah, any of these locked ones here have stuff inside of them, right? So, like this one you can't go inside of, right? No. But, and this one has a dive target, which is a little different, but, there are lots of different things going on here. But anyways, yeah. So there we are. We've got some cool shortest paths going on here. Let's turn that off. Got some wires and things like that. Let's think about what we might want to do with this. Let's maybe only... Oh, yes. That's what I wanted to do. Let's do this. Let's do path cost. So what this is going to do is actually give us the total cost for these paths. So let's now do just a blast. And I'm going to do sort of the same thing I was just doing there before. And we're going to say this is primitives. And we'll do at path cost, I think was the name of it, is greater than like 40, I think. And this will keep just the paths that are, oh, right, because it's deleting them. So we'll delete non-selected, and this will just keep paths that are over 40. Maybe we'll even go up to 45 and just keep a few of them. You know, maybe we'll do these, you know, eight primitives here. And so, you know, I'm just trying to think of now just our best next step here. Let's do this. Let's do, what do these look like? Yeah, they're pretty rough. Let's do a resample on these. And probably don't need it that fine. Let's turn it down to like 0.2. Actually, is that the exact same? No, it's not. Cool. And let's output the curve U value and the curve number value. And so now we should have those that we can use. And so let's do this. Let's take, here's a good point wrangle. This will be pretty quick to write. What we're going to do is write, we're going to write some vex actually in a second. What I want to do is do I love this attribute fade node. It's really fun. I love this. So the fade start, hello? Thank you. Okay. All right, so let's do this. Let's take, let's take, I'm trying to think of the name of this attribute that I want to call it, something that makes sense. So we're going to add f at curve U plus f, or no, this is I at curve num. I think I'm gonna need to cast that, but that's okay. And we're just gonna make an attribute here and call it f at let's call this start time, because we're gonna need to change this to a start frame. So this will just be our start time. Don't forget our semicolon. That's good. Oh, it's not even yelling at me. That's great. Look at that. So what we should have now is a start time that sort of adds our that adds the curve number to the curve U, and then we get these unique values that go along each of them, right? And so what we could do here now actually is offset this a little bit by doing this. We could say float offset equals, and then we'll do ch. Let's see. We'll say we'll call this bolt time spacing, and I need to put underscores in there. I don't know why I typed it like that. That's okay. We're going to do it like this because we need it to be a string. And then when we hit our little plus here, boop, we'll get our bolt time spacing. We need a semicolon there. And so what this will actually do now is it should, oh, actually we just need to do it here. We'll do, let's do this as a, I think if we do float like this, I think that'll work because we need this to be a float now. Or actually, is it I to A? No, I to F. Is that it? Is that it? Sorry, I'm just trying to remember. No, I think we can just do this. I think we can just do float. And do that. Yep. And then that way we can multiply this together properly. So, sorry. Now we will do offset and multiply that times the float of that. I don't have to. That. Great. So now if we change this. Oh, that's right. It needs to be probably higher than. Yep. Because if we turn this down, it actually messes it up. So, actually probably just need to add this, right? That would probably make more sense. No, it's adding it along the whole offset. Let's do offset times 1 plus float. And do that right? I think I added too many there. There we go. Okay. I think that's right. And then if we do this, no, that's not right. Okay. Sorry. This, multiply this here. Don't need this. Okay. And we'll just make sure, well, whatever. This just needs to be over 1, basically. So 1, it's going to be just as it was. If we go a little bit beyond that, we're going to add to each of these. So now this next one's 2, then 4, then 6, then 8, 10, 12, 14, blah, blah, blah. So this is a way to add some spacing between each of these. You'll see in a second what this is doing, basically, but there we go. That's kind of interesting, actually. You could have them all work at the exact same time, actually, if it was at 0. They would all go simultaneously. So anyways, we'll just leave it at like 1.5 for right now. Great. Then we're going to do an attribute remap. This is a super useful node because it will do exactly what it sounds like, remap our attributes. So, oh, actually, sorry. We want to do, sorry. Nope. We want to use attribute adjust integer. This is actually going to be better. Sorry. And we're going to do start frame, and we're going to pattern type from remap attribute. Source attribute is going to be our start time. We can compute that. There we go. That's our range. And so now for our start frame, we can see that we're going between 0 and 9. Actually, I'm just trying to think here. Sorry. No, that does make sense. So let's change this because obviously these are just a few frames, so that'd be silly. Let's have the start frame be at frame 12 and the last frame be at, I don't know, 216, something like that. So now these should all have values that kind of fit in between there. And at these jumps, we should have a few frames in between each of those where there'll be a little jump in that amount. You could do this with some VEX and stuff like that and make this a lot more robust, but we're just kind of doing this sort of rough here just to make it do its thing. So we have these, our fade start frame. Interesting. That is really strange. Is we'll do start frame. And let's just hit play here and see what happens. Yep. So what we're actually getting here is a frame kind of hold. If we watch our fade value here, oh, actually, interesting. Is that not playing back while this is? Oh, maybe I just missed it. It just goes by really quickly, doesn't it? Yep. Interesting. There it is. You can see that fade just rolls down there. So let's timings. That's what we want. Okay. So let's have it be 1 fade in. We'll have it fade out over 12 frames and we'll hold for maybe 6. And this should look a little more. Yeah. So now we're getting something that's a little more lightning-ish. This is kind of like a slow motion lightning shot, right? Because if you're doing this in real time, it's not going to look that cool. So let's sort of just do it like this. We can also give this a bit more time in between the lightning bolts. We could do some randomization there as well. So let's just do that. We'll do 3. We'll just recompute this range. Looking kind of cool. So now we've got some crazy lightning bolts going on there. And instead of calling it fade, maybe we'll call it emit. And you can see how those attributes kind of fade. They snap on real quick and then they fade off. That's what we're doing with this node. I love it. I think it's super fun to work with. It's really cool. I use it a lot. Or I have used it a lot. I guess I haven't used it a lot recently, but okay. So let me just think about this. Is there anything, will we be able to render those? Well, let's see. I don't know. Maybe we'll have to tweak something here, but let's just put a null down here and call this out bolts. Okay. Cool. I like to do this because I like to be able to jump in and out of things. So let's grab our LOP network here. I always name it Solaris in case people aren't sure what the heck they're looking at. So let's do that. We're in Solaris now. Let's get these things in here. So let's do a SOP import. Let's grab our out cloud volume. There it is. And for this, let's say, call this cloud. It's going to be the name of the component. Got a volume 0 with density. Perfect. Let's also grab SOP import another thing here, and we will grab the SOP path to out bolts. And if we just hide our cloud here, we should see that we do have our bolts in the scene here. So that's cool. Looking good. The question is, what are those going to render as? But that's okay. We'll figure those out in a second. And we'll call those bolts. In fact, let's make our scene a little nicer here. So let's do this. Let's call this geo, and we'll add a geo in front of this as well. That's just adding to our path so that we're making our scene graph tree nicer down here to look at and use. So now our geo is going to go in there. We've got our bolts in our cloud. Let's make this a little bigger, like so. Great. All right, so let's do some different stuff than what I've done before. Let's do a what is it? A quick cloud material. Cool. Let's do that. And this quick cloud material is going to make a material in under this primitive. In Solaris, every line here is a primitive technically. So everything you see here is a primitive. It's just a different way of calling things. That's a USD nomenclature. So don't be too freaked out by that. But basically it'll make this kind of null group materials. That's a primitive. And then it's going to make this quick cloud material in there for us. So that's great. And what we should be able to do then is assign these in a second. So I'm going to make a quick cloud material, and I'm going to make a quick surface material. That quick surface material should be able to do our emission, which should be right there. And we'll get to that in a second. So let's just call this, we'll just call this cloud shader. We'll call this bolt shader. Okay. So we've got our two materials in here. And then we'll do an assign material. This is just making our material assignments. And we can just do two material assignments. We're going to grab the cloud and give that the cloud shader. And then grab the bolts. Give that the bolt shader. Oh, did I miss that drag? I must have. There we go. Cool. Oh, one more thing I think I'm going to do here is let's add one more thing in here. Let's do a grid. I just think that might be kind of neat in the render to see like a grid in here. So let's just add a grid in, move it down a little bit like so. Actually, maybe move it even a little lower like that. And this, if we go inside, is actually just a grid, nothing crazy. So let's just do this at like, I don't know, 50 and 50. That's fine. Maybe a little bigger. Do it 100 by, not 1400. Let's do 100, something like that. Cool. So now we've got a nice grid, ground plane. And let's give that actually another quick surface material here. We'll call this ground shader. And this grid, we should also put this into the geo, under the geo primitive. So we'll do that and call this ground. Cool. Ground shader. Yep, got that. Now we just need to add the material assignment. Is it normal to repeat a lesson for newbies in Houdini? I'm not sure what you mean by that. For who to repeat it and in what situation? Not 100% sure exactly what you're referencing there. Is it normal to repeat a lesson? All right, I think I get what you're saying. Is it normal for you as a learner to go over something multiple times to try to make it make sense? I would say yes. I mean, I've done that before. Yeah, you're the newbie. Gotcha. And you're feeling like you need to go over something again. Yeah, I mean, of course, I think that's totally reasonable. I'm not a newbie and I go over things that I've done before. So yeah, I would say that's pretty normal. I don't think you have much to be feeling weird about there. If it feels like it's helping you, yeah, do it, go over something again. I've done that before with really complicated things. If I don't completely remember it, I'll go back and try to like go through it just so I can kind of make sense of it. Yeah, I think that's a reasonable thing to do for sure. I wouldn't look down on yourself if you're like, man, I got to keep going over this stuff time and time again. I do the same thing. Sometimes I'll even look up stuff that I've done in the past to go, wait, how do I do that again? So yeah, it's not that ridiculous. Usually with USD stuff, it's mostly that I'm like, shoot, what did I say was a good idea from that? Mostly because I'm repeating what other people say in those. But anyways, okay, cool. So we've got that. Let's just do a physical sky here. We'll drop this in. And let's not have it too bright. Let's do it like that. And maybe have it be, well, actually, let's leave the intensity up. It's the exposure that I probably want to mess with. Let's actually have the altitude come down a little bit so it's like almost like a sunset thing. So we just have a little bit of ambient light. And all right. So if my audio starts getting weird with this, let me know, because sometimes that can happen with rendering since it's trying to use so much. Oh, you're very welcome, Anton. Welcome. Thank you for joining the stream and being here. Appreciate it. If anything gets weird with my voice, please let me know in the chat. I'm curious. I'm going to turn on CPU. I think that'll be probably cause less issues, but if it is causing issues, please let me know. That's pretty cool. I'm actually going to hide the bolts for right now. There we go. Cool. Great. Thanks, Graham. I know it gets a little weird when I render sometimes. Like I said, I'm on the same machine. All right. So let's check this out. Okay. So the nice thing about these edit material properties is that we can just kind of grab them right there. Actually, you know what? I'm going to do something here. I think I can't think of how to turn those off. Oh, it's layer info. What is that? Right? That's layer info. It just stinks because when I select them, you get all this extra stuff here and it gets a little hard to read. Seems like it just kind of makes it busy. I can't remember how to turn that off. Sorry. All right, I'm going to turn the density up a little bit here. Maybe we'll turn it to like 5 or something like that. That's feeling pretty good. Maybe 4. Okay, cool. The ground shader, I'll leave that there. Yeah, we can just leave it like that. That's cool. Okay, cool. Good. Thanks, Robin. Okay. It's looking pretty good. Now, let's see if we can't get that bolt shader to work. So, one thing to notice here is that if we go into our curve here and look at the stuff next to the geometry spreadsheet, I'm going to stop this. Go back to the Vulkan viewer. If we go into here, we can see that there's this emit value, right? This is what we actually want to read in. So the really nice thing about these quick materials is that we can, let's see, we've got our base here. We don't want to mess with that. That's probably fine. Let's go to emission. We're going to turn that up. Actually, that might be good to just check and see if that's working at all. Let's do that. Let's actually turn, oh yeah, I'm seeing it. Seeing it there. Cool. Yeah, nice. Let's actually just turn the exposure way down on this. Oops. Just so we've got the background in here. It's kind of interesting. Just have a little bit there. Maybe we'll do it at like -5. All right, so what we're going to need to do here is we're going to need to put a karma node down because that's going to have a lot of our render settings in it. I think we're going to need, we also probably want a camera in here as well. Just thinking about that. So let's open this up, grab a camera from there, control click on that. That'll throw us into our camera in line here. So that's good. Okay, I'll just stop everything from yelling at us. And what we want to do is we want to turn our volume limit up a little bit here, I think. Let's do that. And sampling. So let's also take, sorry, let's go back to our bolt shader and put our let's do our color primvar here as, oh, we could actually do this as the display color. That's the name of the CD in Solaris. So if we do this, that should give us, here, let's just turn off our our cloud for a second. Let's turn off the selection, let's turn off the light, and that should, yep. We can see that those bolts are doing that. Okay. And then I think the other thing I actually need to do is a render geometry settings. Maybe here. Let's see. We're going to grab that. The bolts. And let's see here. I think we want to do from light. We're going to set a create. Say yes. I think treat it as a light source. Okay. Is there a geometry light? There is. The only question is, can I... This is exactly what I did, but is there a way to... Let's see if there's a way to... change the brightness of that. Actually, what I'm going to do is change this to Solaris and just see if there's something I'm missing here. Oh, shoot. Object, Solaris. There we go. pretty sure that that is the exact same thing that I just did. Okay. That's basically the exact same thing. Actually, just make sure that that's working. Let's do CPU. Turn this off, this off, this off. Maybe submission set to 1. Ah, yes, it is. You are right. Thank you, sir. Yeah, that's right. That's how you can change it, maybe. Hey, there we go. Now it's doing something. Cool. Good call. Yes, emission is set to 1. Should adjust that like so. All right. So I'm going to go back to my tall one because I like that view a little better. Perfect. That's what I was hoping for. I think this is another reason why I don't love. I literally was trying to fix this all day today. I got somebody about that. I don't know why. That's a side effect from side effect. That's something from a long time ago. I think I had Magic Bullet on this computer like 4 years ago, 3 years ago. Anyways. All right, I've had the backup on and I think we're good. Yep. I had it auto saving, so that's great. Let it do its thing real quick here. Take a drink. All right, there we go. Weird. What is going on there? Yes, we don't want that. Display color. Just leave it at white. Okay. Let's go back. Let's go back to my one that I had from before. There we go. Okay, looking good. Let's go back to Vulkan. Let's turn the cloud back on. I think I do just want just a little bit of something here. Something interesting. It's working. Cool. It's really noisy. Let's see here. I kind of feel like this actually might want to go higher. Something like that. Let's do this at the end and see if that... All right, I'm going to do something a little scary. Let's see. I'm going to change this to XPU, change this to XPU. We'll see how things go here. Hopefully things don't get too nuts. Yeah, it's looking pretty cool. It's definitely doing something. I'm going to have to render this out and see what it looks like, but it's definitely doing some stuff, you know? Yeah, so I think we're getting somewhere here. I think things are definitely things are happening. I really think that I think they updated something in Karma so that it runs the denoiser while this is while this is updating type of a thing, which is nice. So I think if you turn this off, yeah, we can see what that looks like. Definitely not pretty. It's because I have, obviously, my path trace samples are quite low. Yeah, Mattis. Yes, what I'm using is the quick surface or quick cloud material. You do quick cloud material. It brings this up here. So these are all of the shaders. This is my assigned material. These are all of my SOP imports. I gotta see how to turn that off. Let's see here. Maybe it is in the display options. Oh, there we go. What is that? Like, ugh. There it is. Context option dependencies. There we go. That's a little nicer. Oops. Honestly, we'll just hide those. We don't need to see that right now. All right. For now, that's good. Cool. Well, I think we got something interesting going here. Let's see. I thought when you were using the pyro shader that it would be possible to use the scatter volume in combination with a mask. Ooh, man, you're into the parts of my brain that are not very helpful. I don't have a lot of rendering knowledge, so that yeah, I could use the scatter volume in combination with a mask for emission in the shader. Yes, I wasn't doing a pyro thing at all. I'm doing that with a bolt of lightning, right? So probably you would want to, if you wanted to do it that way, you could probably get an emission volume. That might work better. I don't know. I mean, yeah, I mean, that's a good point, I guess. Like, yeah, you could maybe, I'm sure you could do this a million different ways. Um, I'm just kind of winging it here. So, and my idea was more so like, these are little like bolts or something like that that are kind of shooting through this. So, yeah, that's a great question. I think what I'm going to do is probably render this out separately. I might throw it on the Discord afterwards and just be like, hey, check it out. This is kind of what it looked like when it was all rendered. Obviously, it's a little tricky to do that here. Let's go back to camera one. Oh, that is so pretty. You know, maybe it's just it's getting a little too soft there. I feel like I wonder if I think if we do that, it's not going to really do much of anything, right? Oh no, it will. Huh. Yeah, I'm kind of curious what this would look like overall. Like in motion kind of a thing. Oh, the other thing maybe could look kind of neat actually now that I'm thinking of this. Sky atmosphere, I think is kind of cool. Let me see. Yeah, I think that sounds right. The only thing I'm not sure is like how I could like attenuate that, you know? Let me go back to this here. Ah, it's compiling that. Yeah, crank up the emission of it, of the shader. Whew. Let's see. Is there anything in here? No, it's not going to really do much for us. Oh, that's cool. That does actually do some nice stuff. The anisotropy. Oh, yeah. Yeah, because that's kind of blending across the whole thing, right? So that's going to scatter it forward, right? This is backscatter. So maybe just a little less scattering through it, maybe. Maybe it doesn't need to be at 250. Actually, this is pretty bright, I guess. Lightning is bright, so... Yeah, it's definitely changing it. It's kind of cool. I actually think it was doing some stuff in the atmosphere there. Let's do this. Cool. We're doing it. Let's see here. Let's see. What is it called? I don't know how to do the top of my head. It's Fresnel. Fresnel. Sorry, Fresnel. Yeah, I'm not sure. I'm not sure what that would be, but yeah, that's interesting. So this actually has some atmosphere in here too, so that's kind of doing some cool stuff actually. So we'll leave that. We'll leave it as is. I don't know, this is kind of weird, but whatever. Just wondering what I like. Just wondering what that value there is. It's kind of interesting. Or what's going on here? Kind of weird. Anyways, yeah, I think that's looking pretty cool. The old machine's definitely heating up over here from all the render. But yeah, it's looking pretty good. Cool. Well, I think that might be where we're going to call it for the evening. Maybe I'll just let it sit here and render out an image real quick. Just see what it looks like with no denoiser. Wow, it's really noisy. We'll just leave that on for a second. So, yeah, I think we're getting something kind of interesting here going. Maybe play around with it a little bit. Maybe I'll just let it render out some frames. Yeah, no, it looks like the ground is set. Yeah, I know. That's what I'm seeing too. But what it is it's actually the atmosphere that I threw in here. So there's the ground, and the atmosphere does some really nice stuff to like everything. But let's try this. Let's try turning this down even more. So I just want like a little atmosphere in there, like a little like light to hit it, I think would be nice, just to give it a little something. So maybe like that, but not really seeing any bounce from it, which is kind of too bad. I was kind of hoping you'd see some light on the ground. Oh, wow. That's really bright. Holy cow. Guess 1,000 might be too bright. Yeah, it definitely is something with the, like, because when I do this, it gets this like weird, I don't know. It's so strange. Like, I don't understand that. Oh, I don't know what that even means, but that's cool. I wonder if I just do this. Maybe I just need to lower the sea level by like 1. Yeah. Oh, that's fine. Where's that sun? Where'd that sun go? How far down did I put the ground? 4.6. Clearly doesn't matter. Whatever. That's fine. Oh no, you can't hear me anymore? Oh, sounds fine there. Oh, okay. Weird. Anyways, yes, I think maybe restart the stream. That might help, but I'm going to be closing things down anyways here. Cool look and storming here. Great. Well, yeah, I think that's where we're going to end the stream for the evening. Thanks everybody for tuning in. Got a pretty nice little result here. I'm excited about that. So I'll have to maybe render that out and see what the final looks like. See what we can come up with. So that might be in the next couple days. I might maybe post that on somewhere online. But yeah, thank you all very much for joining and for your comments and for helping me with rendering, because clearly that is not my specialty. But yeah, we all got there in the end, so that's kind of cool. Maybe even learned a little something about Solaris tonight and see some cool stuff. But yeah, I think that's, like I said, that's where we'll end the stream for this evening. So if you are interested in joining the Discord server, feel free to go to Houdini Hangout, grab the link there for the invite, and that will get you that'll get you to the Discord server. You can put in suggestions for future streams there, talk with people about maybe things that they're working on or things you're working on, and a whole bunch of other stuff. So thank you all very much for joining this evening. Thank you for commenting and all that type of stuff in the chat. And we will see you all. Oh, actually, sorry, we won't see you next week because I'll be up at the Horizon event next week in Toronto. So I will not be able to stream on Wednesday. But we will be we'll be up there doing that. So keep an eye out for a lot of great content coming. And then the next week I should be back. We should be back. Oh, good. Your sound came back. Great. We should be back the week after that, back doing some stuff. So, too bad. No passport. Well, the videos I don't think will take too long to get up. And they should be, because they're all being recorded by us. And a lot of them they're all kind of, a lot of them should be able to get up online and you should be able to see those pretty soon. So, yeah, should be good. Hopefully it won't take too long to get those videos up because it's a very controlled environment. So, anyways, thank you all for being here, for joining. We will talk to you next time, and have a great night. Enjoy the beginning of fall here. It seems like we're starting to get close to it. So, we'll see you in a couple weeks, and thanks for joining. Bye, everybody.